All right, so let's do one more example. So just like all the others, the first thing that we're going to have to do at the top of this one is factor. And this one has a GCF at the top, so the 2 factors out, and that leaves me x squared minus 9, which is a difference of 2 perfect squares. And then I need to factor the bottom. Doing like we've done on the others, I'm going to check the degree. The degree at the top is 2, the degree at the bottom is 2. So they have the same degree, which means my horizontal asymptote is the lead coefficients. So y is going to be 2 over 1 or 2. If you have a horizontal asymptote, you do not have a slant asymptote, so that's none. Setting the top equal to 0 to get my x-intercepts. The 2 kind of can disregard that. 2 equals 0 is just nothing. So x minus 3 and x plus 3 both set equal to 0. So my x-intercepts are x equals 3 and x equals negative 3. I'm going to go ahead and put dots right there. I don't have any RD because none of my pieces match. And I only have 1 vertical asymptote because I have x plus 1 on bottom twice. So there's 1 vertical asymptote. I'm going to draw that in. So go ahead and draw in your horizontal asymptote this time because it's not the x-axis, which is going to change just a little bit about this. All right, so again, my critical values. So remember, critical values are just x's. So the horizontal asymptote of 2 does not apply here. It's just the 3, the negative 3, and the negative 1. So I draw in my asymptote of negative 1, and then my 2 zeros or x-intercepts. We're going to check positive or negative in each location. Even though x plus 1 is written up there twice, you need it because you need to know if you end up with a negative times a negative on bottom. So put all the pieces. Checking all those values to the left of that first 0, I get negative, 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 negative. They would all be negative. Checking between my 0 and my vertical asymptote. If I plug those values in, negative, positive, negative, negative. Checking between your vertical asymptote and your other 0. Negative, positive, positive, positive. And to the right of that last 0, everything's positive. All right, so that means my entire function would be 4 negatives makes a positive. And then I've got 3 negatives makes a negative, negative, positive. All right, so now we have an issue here that we didn't have before. I have these 2 x-intercepts, but I also have a horizontal asymptote at y equals 2. And I need to know, can this graph cross the horizontal asymptote? So the way that you check that, we didn't have to do that before because we knew it did when we found our x-intercepts. But this time I have to check. So I'm going to take my entire function and set it equal to my horizontal asymptote. Now this is just algebra. All numbers are understood to be over 1. I'm going to cross multiply. So I get 2x squared minus 18 times 1 is 2x squared minus 18. And then 2 times x squared plus 2x plus 1. And now at this point, you're just solving. This is just algebra. I'm solving for x. If I get an x value, then that means this particular graph crosses my horizontal asymptote at that location. So I'm going to go ahead and I'm going to distribute my 2 into the right-hand side. So I end up with 2x squared plus 18 equals 2x squared plus 4x plus 2. And then again, I'm just solving for x. So this is just algebra at this point. So I'm gonna, my 2 x's cancel each other out, and that leaves me negative 18 equals 4x plus 2. Subtract 2 from both sides. I get 4x equals negative 20, divide by 4, and x equals negative 5. That means I have a dot at negative 5, 2 on the horizontal asymptote. So I'm going to go ahead and put a dot there. This is where this graph crosses the horizontal asymptote. So now I'm going to use all of the behaviors that I've figured out, and I'm going to sketch a graph. So I know that on the left-hand side, it has to be above the y-axis. So I've got positive, negative, negative, positive. So it has to be above the x-axis, but it also has to pass through and go above the horizontal asymptote. In between that 0. Now, right after the 0 and before the vertical asymptote, it goes negative. So that's going to go below the x-axis. So right here at this 0 to the vertical asymptote, it goes below the x-axis. And then the other one is below the x-axis all the way to the other 0, where it goes above the x-axis. However, it does not cross the horizontal asymptote. So it looks something like that.